Well, hello everyone. My name is Chiranjeevi, and in this video, we are going to learn the Singleton creational design pattern. So, we'll quickly have a look at the definition and then the problem it is trying to solve, and then the UML diagram. We'll try to implement this in Java using the most efficient method with enums. So the singleton design pattern is actually a very interesting pattern, and over the years there are so many ways to implement this singleton pattern, but each of the ways having some problems which we get into when we try multi-threading in Java. So we'll quickly have a look at one of the most efficient solution for implementing the singleton pattern in Java using enums. So let's get started. So the singleton design pattern is a creational design pattern that lets you ensure that a class has only one instance, and it provides only one point of global access to this instance. So this is the problem statement which singleton design pattern is trying to solve. Let's say you have an application and you have a global state which you want to maintain over the entire life cycle of the application. How would you do that? You will definitely not want to have two global states which you are referring to, and because it will cause differences in the behavior what you actually expect and what you actually get. So let's have a let's have a look at the problems we are trying to solve with the singleton design pattern. As discussed in the definition itself, it says that we only have to ensure that the class has only one instance over the entire life cycle of the application you're running. And there is only one and only one way to access it globally from anywhere in the code. So let's have a look at the UML diagram and the general way of implementing this pattern. Then we will quickly look at how to implement this using enumerations in Java. So this is the UML diagram for singleton design pattern. As you can see, we have the main class which is asking for the global object, which is our singleton object, from a class which is called single object. And as you can see, there is a instance variable which is of type single object, which is a private variable. And also one more thing to notice here is that the constructor for the single object is also private. So we don't allow client code of this class to invoke the constructor on the fly. On the other hand, what we do provide is a get instance public method. As you can see, we have a plus sign here, which returns an instance of this single object. So the idea behind making this constructor private is that we force the client not to call the constructor so that they will not be able to create multiple instances for our singleton class. And the way we do this is by preventing access to the constructor. Also, by the way we implement the get instance method is if and only if the instance of the singleton has not been initialized, initialize it and then return it, else return the already instantiated object. But now, as simple as this UML diagram looks like, it's not simple to implement, because there is no problem which you will face if you are not working with multi-threaded applications. But if you are working with multi-threaded applications and you want to share this state, it will be a very horrendous task to create the singleton instances, as multiple threads can access the singleton object at the same time and result in creating two different objects. So people have already solved this problem with our singleton design pattern, and we are going to take a look at the implementation in Java which uses enumerations. So you might have observed that I have been talking about enumerations and the implementation of singleton using enumerations in Java. We'll quickly see why it is so important to use enumerations instead of classes with private constructors and having a public get instance method. We'll discuss how the loading of the object occurs in case of an enumeration. So let's have a look at the code and we'll try to explain the behavior which is going under the JVM. So as we saw in our UML diagram, we had only two methods for this singleton design pattern. So one is our main method, which will actually be the client of our singleton, and the other class is the singleton itself. So I'll quickly go over what I'm doing in this class, and then we'll go to how this singleton design pattern is working. So the best way to implement singleton design pattern is to create an enumeration in Java with only one instance of the enum, and this instance will have all the values whatever you want in the global state. So for the kind of simplicity, I have taken only one value which is of type integer, but you can have multiple values like float and double and other your customized object types. So let's remove it from now and try to look at how is this working. I've also added a getter and setter for the singleton, so I could manipulate the value in the singleton. And let's quickly go to our client, which is our main method. And here what we see is we are trying to create a singleton instance, and we are trying to get it from our enumeration by doing our enumeration name dot the enum name. Then we are trying to set the value for our value primitive integer key in our enumeration to 4, and we are trying to print that value. So as you can see here in the console, the first print line statement is printing the value 4. Now, what we are doing is we are creating one more reference to our singleton instance, and we are trying to get the value from the another reference and try to see what is the value. And we can see that the second print line statements also prints out 4. And this is because even though there are two different references for singleton and for this singleton instance, singleton and singleton 2, both of them are pointing to one global variable which has the same value on the heap. Now what we did is we tried to modify the value using the first reference and again try to print that value using both the reference, and we see that the value gets updated for both the cases. So this is how singleton design pattern works. It tries to maintain a global state across the application lifecycle and tries to give you a way to maintain a state over the application, which can be controlled through several different places as you like. So that's enough with the working of the singleton design pattern. Let's discuss why this enumeration approach is the best approach to implement a singleton design pattern. So this is the traditional way we implement the singleton design pattern. What you have here is an instance of private instance of the same class you are using for your singleton, and you have appropriate fields and values to it. And as you can see, the constructor here is private, which is taking a value and assigning it to the value. We have a get instance method as we saw in the UML diagram, which is public, and it checks whether the instance is null or not. And if it is null, it actually instantiates the instance by calling the private constructor with the appropriate value. If not, what our instance does is actually return the instance which is already there with the class. So we'll now discuss why we should not follow this approach and why we should go through our enum based implementation. So the problem with this code is that if you are on a highly concurrent systems and if there are multiple threads which are trying to get the instance of the singleton, what you can possibly get is end up is having actually two different instances of the singleton. What could happen is one thread can come here in the get instance method and try to do a check whether that instance exists or not, and then sleep without creating the instance. And in the meantime, the thread is already sleeping. The second thread can come there and actually check whether there is an instance or not and actually instantiate that. Well, after this, when the first thread wakes up again, it will actually don't check whether the instance already checks again because it has already checked it, and it will again go through the process of instantiating the object again. So in case of highly concurrent systems or multi-threaded systems, this approach is not useful. On the other hand, in our enum-based singleton, our instance variable is a static final constant which only gets initialized when we reference it for the first time. So the first time we try to reference our singleton enumeration instance, uh, the object is instantiated by the JVM itself on the first reference, and after that, JVM takes care of managing the threads accessing the singleton, so it doesn't end up having multiple instances. So this is how enum based singleton actually supports multi-threaded environments. But the problem with the enumeration based singleton is that if you try to serialize and deserialize it back again, you will lose the value for the instance. So as you can see, based on the scenario you are into, if you're not actually coding for a highly concurrent or multi-threaded system, this is actually a good way you can go through if you guarantee that not more than one thread will be using the get instance method for the creation of the singleton. So that's it, guys. We have discussed the singleton design pattern and we have looked at what is the problem it is trying to solve and various ways how you can actually implement the singleton pattern yourself. If you have any queries, you can ask it in the comments and I'll try to answer that. So thank you guys for watching this video and I'll see you in the next one.